Welcome to this course on business statistics. In this course, we're going to learn all the basics needed to know about how to make your statistics course a little bit fun, easy, as well as understandable. Statistics are widely used in a number of different organizations and domains, and they're critical for ensuring that we understand how to read and interpret data accurately, whether you're in healthcare, media, marketing, or any other discipline for that matter. Every single industry uses data. It is everywhere. We collect enormous amounts of data, including data on products, sales, customers, patients, what have you. This data is used in a number of ways. We'll describe the data to tell us what's happening with particular customers or patients, as an example. We might use that data for predictive modeling later on, and even use it for machine learning and artificial intelligence algorithms. And while the application and use of every single piece of data and every model and technique is different, the benefits are clear. For example, accounting might use data to help identify insights into the financials of a company, things that could be used for audits or accounting forensics, as well as to explore efficiencies or inefficiencies thereof in operations. In finance, we may use it for financial models or investment decisions that are complex, and real estate predictions as well. Other industries such as healthcare could use it for identifying patients that are more at risk of a certain comorbidity. In marketing, we might use it to understand our customers, our products, for different marketing campaigns, or to create new products or new packaging. We can create classification models, identify target prospects and customers. We can even predict sales and traffic within stores. The use of it is to help us with a better operations, better efficiency within our organization. Companies that are more operations and logistics oriented will rely on the data to increase those efficiencies within their production lines and transportation. For example, if you had trucking lines and you wanted to make sure that you maximized the trucking routes or what goes on particular trucks to go to different stores, we may use it for that. But we can collect data on everything from time and performance of trucks to the production line, as well as pull external data such as weather data to help identify or predict issues that may occur within distribution. In information systems, which is similar to operations, we're going to use that data to improve efficiencies in our operation, and we can utilize it to identify network attacks, traffic on websites, and even data on internal employee calls to the help desk to provide a more efficient support operations. Now, what's the first step in any analysis? The first step is to ask the right question. Analysts have to be clear about what we're looking for. Questions such as, can we predict our sales for the next 3 quarters? Or, does one teaching method do better than another? These are questions that are searching for answers from the data. In order to accomplish this, we must identify the entities that are being studied. These entities are known as elements. Elements themselves are the entities that are being observed or studied, such as hospitals, states, or countries. In addition to the above questions, the entities could be considered sales if we're looking for sales forecasts, or the entity for teaching methods could be the students if we're focused on their performance. Now, at a basic level, the data set itself consists of a number of columns and rows, which are the variables and observations respectively. So the columns here represent our variables, and the rows represent the individual observations or units that we're looking at. Some large data sets are not in rows and columns, and those are consisting of unstructured data like audio, video, text that might occur from a newspaper article. Those are what we call unstructured data and are not in this course. So a variable therefore represents an attribute or a characteristic that is being observed, such as the height or weight of a student or height or weight of a patient. Those refer to our columns. An observation represents a collection of variables, a record or data points for a row. So everything across the row will be the observation. Collecting 10 questions from an individual respondent, therefore, would be considered an observation. Now, the data that we collect is measured in some information about the variable. A scale is considered a way to measure something. Whether we're talking about data such as temperature, grades, or movie categories, all of these are measurements. There are 4 types of scales. A nominal scale, which is a variable that consists of labels or names. These could be like movie names. That might be a nominal scale. An ordinal scale is a variable where order has meaning, such as student rank, movie ratings, bond. There are 4 types of scales. A nominal scale, which is a variable that consists of labels or names. This might be something like a city, New York City, San Francisco, Los Angeles, if we're looking at data from only those 3 cities. An ordinal scale is a variable where order has meaning, such as student rank or movie ratings. Everything is in a certain order, and that would be our ordinal scale. An interval scale is always numeric and has ordinal properties. So, for example, an SAT score that will range from, say, 400 to 800 would be an interval scale. Now, there is an order to it, but there are a lot more numbers, and it acts like a number, and therefore it becomes an interval scale. And a ratio scale is if the data can both be ordinal and interval, and the ratio or the division of the 2 values has meaning, then the data is a ratio scale. So, for example, a temperature, a height, and weight would be considered a ratio scale. Now, there are 2 categories of data in general. One is a categorical set of data, the other is continuous. Continuous data contains numerical information such as the height and weight, and every number in between means something. So if someone's height was 67, 66.8 is just as meaningful as 66.89, and that is continuous. Every point between any 2 points has a meaning. The example above demonstrates that they're really numbers, and they are used as such. In general, just because a data point is a number, though, does not make it continuous. Consider a column like an ID, and everybody's given an ID number 1, 2, 3, 4, 5, and so forth, or another field that has location 1, 2, 3, 4, 5. Those are numbers, but they're not really continuous data because the numbers between the numbers don't mean anything. 1.5 doesn't mean anything, and so it's not really used as a numerical value. Now, categorical data is information that can be broken down into groups. For example, male, female, old, young, high, medium, or low. Different values of categorical data are known as levels. So, in the case of that gender, I had 2 levels, male, female. In the case of the age, I had old and young. And in the case of value, I had high, medium, and low. Those would be 3 levels. Categorical data can thus be broken down into a few groups. Discrete data, which is categorical data that is countable, the number of students in class. I have 10 students, 11 students, 12 students. 11.1 students doesn't really mean much. Binary data, which is categorical data that basically has 2 possible values, 0 and 1, male, female, high and low. In the case of nominal data, where I have a third category in that example, it's categorical data where the order doesn't matter as much if you had New York, San Francisco, Los Angeles. So if the order doesn't really matter, it's really nominal. But the minute order matters, where I need to rank certain things, in the high, medium, and low case, it could be ordinal as well. It will most likely be. Quantitative data is data that is numerical or quantity in nature. It can be continuous or discrete. For example, the count of chairs in a room is what we would call discrete because, again, the numbers between the numbers don't mean anything. Or the weight of cars, let's say 1.2 tons, 1.25 tons. Both of them are quantitative in nature because they have a number representing them. It's a little confusing in terms of quantitative, which just means a number, but they can be categorical or discrete and continuous separately. Cross-sectional data are data that is collected from a number of subjects at or around the same period of time. Collecting data around the same time is important to ensure the analysis of subjects is relatively the same. For example, if I'm doing a study on diabetes, I may collect data from 500 people, which should be collected over the course of a few weeks. The data that I collect in that few weeks might be different than if you had collected it 6 years ago. In time series data, it's data that's collected over a period of time, and we also call this longitudinal data. This data is useful in taking into account the effect of time. So we might take a stock price every day over the last 5 years, and time plays a role in the movement of that stock price. And there are financial methods that take this into account, but we would call this a time series data set.